A warm greetings to one and all. In this session, let's learn about Introduction to Probability Theory. Introduction to Probability. So as a part of introduction, let's start with a quote. Probability theory is nothing but common sense reduced to calculation. It is given by Pierre Laplace in 1812. So now let's check out what is probability. So we are all familiar with the phrase, the probability that a coin will land head is 0.5. So it is used to analyze the chance of occurrence of an event. The probability value always lies between 0 to 1. Here, 0 represents event not occur. 1 represents event will occur. 0.5 represents that event is equally likely to happen or not happen. Probability of an event can be formalized as P of E is equal to number of favorable outcomes divided by total number of outcomes. If we toss a coin, then outcomes are heads and tails. Can be either head or tail. The possible outcomes are head and tail. The probability of head is represented as P of H is equal to 1 by 2. Since the favorable outcome is head, it can be happened only once if we toss a coin. The total number of outcomes while we toss a coin is 2. That is, it can be either head or tail. So it is written as 1 by 2. Finally, the probability that a coin will land heads is the probability of heads is equal to 1 divided by 2 is equal to 0.5. Actually, there are two different interpretations of probability. The first comes frequentist interpretation. Here, probabilities represent long-run frequencies of events. For example, the above statement means that if we flip the coin many times, we expect it to land heads about half the time. Bayesian interpretation. Here, the probability is used to quantify our uncertainty about something. Hence, it is fundamentally related to information rather than repeated trials. In the Bayesian view, the above statement means we believe the coin is equally likely to land heads or tails on the next toss. Sample space and event. Sample space is nothing but set of all possible outcomes of an experiment. Example, if we roll a single dice, then the sample space consists of the values 1, 2, 3, 4, 5, and 6. So these are all the possible outcomes when we roll a single dice. If we toss a coin, then the possible outcomes are head and tail. The sample space to represent while we toss a coin is S is equal to H comma T. Event. Event is any collection of possible outcomes of an experiment. That is, it is a subset of sample space. Example, on tossing a coin, we may be interested in observing whether the outcome are head event, that is, event is equivalent to H, or it may be tail event, that is, E2, which is equivalent to T, which is a subset of the sample space S is equal to H comma T. There are many types of events, namely independent. If the event is independent, here each events are not affected by other events. Next, dependent. It is also called conditional, where an event is affected by other events. Next, mutually exclusive events cannot happen at the same time. Now let's learn the fundamental rules and probability. Probability of a union of two events is also called as sum rule. Let's consider two events, namely A and B. We define the probability of A or B as probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B if A and B are not mutually exclusive. So not mutually exclusive means it is possible for both the events to occur together. Let's represent the same in Venn diagram. So here The S represents the sample space and event A is represented in this circle and event B is represented in this circle. So the common area is called as A subset B. So when events are not mutually exclusive, it is possible for both the events A and B to occur together. Next, probability of A union B is equal to probability of A plus probability of B. If A and B are mutually exclusive, it is also called as disjoint event. So this is the Venn diagram which represents the mutual exclusive events of event A and B. So this is the sample space S where we have event A separately and event B separately. Here, there is no possible for both events to occur together. So it is called as mutually exclusive or it is also called as disjoint event. Let's consider an example with sum of rule for mutually exclusive. In a class of 30 students, that is a sample space S is equivalent to 30, and each student is asked to choose their favorite color from a list of colors. The list of colors are yellow and blue. The favorite colors are recorded and it is turned out that 8 students preferred yellow color and 5 students preferred blue color. Suppose no students prefer both yellow and blue color. The event is mutually exclusive. So we need to find what is the probability that random selected students from these class preferred either yellow or blue. So the given data are total number of students, that is n is equal to 30. A number of students who preferred yellow color is n of y is equal to 8. Number of students who preferred blue color, that is n of b is equal to 5. The probability of A union B is equal to probability of A plus probability of B if A and B are mutually exclusive. And the probability of particular event is denoted by number of favorable outcome divided by total number of outcome. So the probability of A and probability of B can be written as 8 divided by 30. That is number of students who preferred yellow color divided by total number of outcomes. That is total number of students inside the class as 30. So 8 by 30. Next, the number of favorable outcome. That is the students who prefer blue color is 5 and total number of students is 30. So 5 by 30. It can be written as 8 plus 5 divided by 30 and P of A union B is equal to 13 by 30. Hope you are clear in this problem. Let's consider the example with some rule for not mutually exclusive event. Let's consider the class of 30 students and 8 students have participated in band and 15 students participated in sports and 5 students have participated in both band and play. Let A be the event that students have participated in band and B be the event that students have participated in the sports. First, let's create the Venn diagram and we can find the sum rule. So the Venn diagram is represented here. So S is the sample space where there are 30 students inside the class. And the event A represents the students who have participated in band, that is total 8. And the event B represents the students who have participated in band, that is total 15 students. And here there are 5 students who have participated in both band and also in sports. Now let's solve the problem. Here the equation is probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. If A and B are mutually exclusive, which means that they have common occurrences. Now we can substitute the values of P of A, P of B and P of A intersection B. That is 8 students have participated in band out of 30 and 15 students have participated in sports out of 30 and 5 students are common in both band and sports out of 30. So we have to add 8 plus 8 divided by 30 plus 15 divided by 30 minus 5 divided by 30. The value is 8 plus 15 minus 5 divided by 30 is equal to 18 divided by 30. Therefore, the probability of A union B is 3 divided by 5. Hope you are clear in this problem. Conditional probability is defined as the probability of any event occurring when another event has already occurred. That is, it calculates the probability of one event happening given that a certain condition is satisfied. It is represented as probability of A given B, which means the probability of A when B has already happened. Conditional probability formula is probability of A given B is equal to probability of A intersection B divided by probability of B, where probability of A intersection B represents the probability of both events A and B occurring simultaneously. Probability of B represents the probability of event occurring. Joint probabilities of two events A and B can be defined as probability of A comma B is equal to probability of A intersection B. That is, it can be rewritten as probability of A given B into probability of B, which is called as product rule. The marginal distribution is defined as probability of A is equal to summation of probability of A comma B is equal to summation of probability of A given B is equal to B, and probability of B is equal to B. Product rule for independent event can be defined as probability of A intersection B is equal to probability of A into probability of B. Product rule for dependent events can be written as probability of A intersection B is equal to probability of A into probability of B given A. Let's have an example with product rule for dependent event. The product rule for dependent event is defined as probability of A intersection B is equivalent to probability of A into probability of B given A. Let's have an example here. Mr. Rama has to select two students from 35 girls and 15 boys to be the part of a club. So we have to find the probability that both students are girls. So the given data is the total number of students, that is 35 girls plus 15 boys, is equivalent to 50. Now, the probability of choosing the first girl, that is P of girl 1, is equivalent to total number of girls divided by total number of students in the class, that is 35 by 50. Next, the probability of choosing the second girl, that is P of girl 2, is equivalent to, since we have choose the girl 1 already, we have to reduce 1 from both girl count and also in the total students of the class count. So it becomes 34, that is 35 minus 1, and 15 minus 1, that is 34 divided by 49. Now, the probability that both students have chosen girls are probability of girl 1 and girl 2 is equivalent to probability of girl 1 into probability of girl 2 given girl 1. That can be written as 35 divided by 50 into 34 divided by 49, which is equivalent to 1190 divided by 1666. The probability that both students are girls is equivalent to 85 divided by 119. Hope you are clear in this problem. Let's have an example with product rule for independent event. Product rule for independent events is P of A intersection B is equal to P of A into P of B. So the example is Kelvin has 5 different ties, 6 different shirts, 4 different pants to wear in his wardrobe. Of those clothing items, Kelvin has exactly one green tie, exactly one gray shirt, and exactly one pair of black pants. If Kelvin randomly selects each item of clothes at random, what is the probability that he wears the green tie, gray shirt, and black pant? So we know that probability that Kelvin would wear randomly selects the green tie is equal to 1 by 5. Probability that he would randomly select gray shirts is equal to 1 by 6. Probability that he would randomly select black pants is 1 by 4. These events are independent, hence the probability that he selects green tie, gray shirt, and black pants is 1 divided by 5 into 1 divided by 6 into 1 divided by 4 is equivalent to 1 divided by 20. The events are said to be independent that he has exactly one green tie, exactly one gray shirt, and exactly one pair of black pants. Hope you are clear in this problem. Thank you all.